Appreciate you all coming out on a 9 a.m. after a party on Friday. I won a beer because there's more than 20 people in here, so that's my first win of the day. My name is Bill Volks, and I'm going to be talking about privileged access workstations and some other ways to limit credential theft and lateral movement in your networks. A little bit about me. I'm Blue Teamer on Twitter. I work in the financial sector for a small company. About 100 employees in 10 locations. Working for a small company usually means you wear a lot of hats. And, I do everything from configuring networking equipment to vendor management to daily sysadmin stuff and a little bit of physical security and just a wide range of different things. And, I'm truly blessed. I'm one of those people that I truly love what I do for a living, like a lot of you guys probably. I'm pretty passionate about it. And one of my favorite things to do is to learn offensive techniques, bring them back to my network, kind of take them apart, figure out countermeasures for them and detection mechanisms and things like that. So in my free time, I like to build stuff with my hands. As IT people, we don't always get to see the tangible thing that we built. And I just think there's something really cool about, stepping back after a long day of work and you see that cool thing that you built. This summer I built a pirate ship with my kids in my backyard, which was a lot of fun. I also like to brew my own beer and cook. Yeah, home brew. And also do lots of cooking and stuff on the grill. Okay, so let's start here by talking about a typical attack scenario on a Windows network. In this first case, let's say that the organization might not be very security conscious. Most of their users are going to be running as local admin, and one of them gets popped with a phishing email. Now the attacker is going to be running as local admin. They can migrate to system, dump credentials, and it's probably not all the realm of possibility that the IT admins set the local admin password the same for all their workstations just to make their lives easier. And if they did that, the attacker can he can use that local credential to log in, move laterally throughout all those workstations that have that password until they find another workstation where maybe a domain admin has logged in. They can steal those credentials through various ways. So it's a pretty quick path to game over. Okay, in the next scenario, let's say that they're a little more security conscious. Most of their users are running as standard users. And same situation, user gets popped by phishing email. And now this time the attacker's running as a standard user. So they're going to need to be able to escalate privileges so that they can get to local admin and then system so that they can dump credentials, steal tokens, and things like that. And one way to do that, they may use something like Harmjoy's power-up tool to look for common misconfigurations on the system that allow them to escalate privileges. If they don't see an easy way to do that, they might move laterally with those standard creds and look for more misconfigurations, just trying to find one that'll work for them. And while they're doing that, they'll probably be looking for credentials that are just on the network. So maybe the admin team left unattend.xml file that they were using to deploy images for PCs, or maybe they deploy passwords to the group policy preferences, and the attacker could get the password that way. But one way or another, they're gonna keep moving around laterally, stealing credentials until they either get domain admin or some kind of privileged credential, or until they get what they're looking for. So these scenarios are certainly not all-encompassing, but I think they do follow a pretty common path on a Windows network that an attacker might take. And like I said, domain admin may not be the end goal. If they find what they're looking for on an open share from the first box they pop, which is a standard user, they may not care about domain admin, but the point here is that the attacker tactics tend to revolve around finding and using existing credentials on a network. And if you want to see a really good demo of how attackers do that, how they move laterally and sniff out credentials, check out Will Schrader and Andy Robbins' talk from B-Sides Las Vegas on Bloodhound. Some really cool stuff there. But the main goal of these privileged access workstations is to limit this exposure, right? But in order to do that, you need to understand where credentials are stored, in what form they're stored, and then it's good to know some of the other issues with Windows authentication and credentials. So to start off here, to give you a little background, like for Windows logon types, there's different logon types within Windows. You know, when you log on to the system, interactive would be like when you actually type your password into like the console, or when you type your password in the computer. That's going to be interactive. And there's a bunch of other logon types. But the key thing to take away here is that all of them, except for the network logon type, are going to leave some form of reusable credential when you use it. So that's a pretty key thing to take away here as we're moving along. And network logon types are going to be things like net use from a command prompt, PowerShell remoting, remote registry, using MMC snap-ins to connect to remote machines. All those they're not going to leave any reusable credentials on the system that you connect. Okay, so let's talk a little bit about where credentials are stored on Windows. One of the more commonly known ones is like the local SAM database, which is a file on local computers that has, you know, all the local user accounts and then their hashes that are associated with them. And these can be dumped with system rights, and you know, which is pretty trivial to get once you have local admin. Once they're dumped, they can be brute forced offline or passed to other systems, which we'll get into in a little bit. You know, Active Directory database, pretty basic stuff here. I think most people know, but just kind of covering where all the credentials are stored. Active Directory database, same thing, only it's credentials for all users in the domain. Now, read-only domain controllers by default aren't going to store privileged credentials, but they'll only have a subset of the database in there. But I'm not going to get too deep into diving into Active Directory and domain controller security, but it is good to remember that's another crucial concept to consider. Credentials stored in LSASS were made famous by tools like Mimikatz and Windows Credential Editor, and you know, those tools pull the credentials from memory of that process. When a user logs onto a system, LSASS will cache your credentials. So when after you log on, when you go to access a network resource, you're not having to type your password in every time. And these can be stored as hashes, Kerberos tickets, or just the actual plain text password. So prior to Windows 8.1, Server 2012, LSASS stored a lot of credentials in memory. As you can see here, they've made a lot of progress in that department. You know, this chart actually comes from the second Pass the Hash white paper from Microsoft, but it was originally adapted from a Twitter post by Benjamin Delpy, who's the creator of Mimikatz. And I find that kind of fitting because, you know, it's because of people like Ben and other people in the community, you know, like Chris Campbell and Skip Duckwall and lots of other people that have really brought these issues in the spotlight and kind of forced Microsoft to give us more tools to mitigate these issues. So I just want to kind of point that out and say thank you to everybody that was involved in that. But this KB 287-1997, also known as Mimikatz KB by some, was released in 2014, and it gave us a lot of the controls that we're going to be talking about today. For example, as long as that update's installed on a Windows 7 computer, the only plain text credential is going to be the wdigest provider in LSASS. For Windows 8.1 and above, there's going to be no plain text credentials stored by default, but there are some caveats to this. It is going to store NT-hash and Kerberos tickets for domain accounts for Windows 7 or Windows 8.1 and above. And also, the third-party SSP might store, some third-party software might store credentials in LSASS as well. This screenshot here from the Mimikatz GitHub page has a whole bunch of really good stuff on it. Some caveats to the plain text credentials. If it's a domain computer and it can't access the domain controller, the Kerberos provider might store some credentials in memory. Although Windows 8.1 and above does not store plain text credentials in memory by default, it can be re-enabled with a registry edit and a reboot. Similarly, Windows 7 wdigest can be disabled by a registry edit and a reboot too. These highlighted registry keys here, if these have certain values in them, it also might store some plain text credentials in memory. For example, if the organization has a group policy that sets allow delegating default credentials for auto logon and for like remote applications for terminal server, that will also store, that'll put some keys into those registry keys that I highlighted in the last slide that will store plain text credentials in the TSP KG provider for LSAS. So a good thing to keep in mind there. LSA secrets are going to be data that's only accessible to the system process. Some of these are going to be credentials that are encrypted and stored on disk. This is going to be things like scheduled task passwords, computer account passwords, service account passwords, and also cache, what we typically call cache credentials, which Microsoft calls password verifiers, are stored in LSA secrets. And these are stored as salted hashes. And these can't be passed in a pass the hash attack, but they can be dumped and brute forced. And you know, the cache credentials being that when you bring your computer home and can't talk to the domain controller, you're able to log in with that account because it's cached on the system. There's also a credential manager where passwords can be entered manually in the control panel, or when you tell Windows to remember your RDP password, it'll store it there. These are encrypted with a key that comes from that user's password, and any program that's running as that user can access those. And there's actually a Metasploit post module that will dump those out, I believe. Okay, so that's kind of where credentials are stored. Some of the common issues with Windows credentials, you know, I think we're all pretty familiar with pass the hash. If you're not, there's a ton of documentation on the internet without being my references. You know, NTLM hashes can be acquired from various ways, whether it be pulling them from memory with something like Mimikatz or Windows Credential Editor, or dumping them from the local SAM or the Active Directory database. And once you have the hash, you can authenticate just as Windows does in a legitimate logon in the background by passing it to other systems on the network. And when you log on via NTLM, there's a couple different flavors of the protocols that it uses, and it does a challenge response mechanism that proves that the user knows their password hash, basically. There's a couple different flavors of that. There's NTLM v1, which is completely broken. If an attacker can capture the traffic on the wire, they can recover the hash. NTLM2 a little bit better, but still has issues, can be brute forced. And both of these are vulnerable to relay attacks, which I believe can be partially mitigated by SMB signing, but not totally. Similar issues with Kerberos, you know, you can dump a ticket from one computer, load it onto another computer, also known as pass the ticket. The tickets technically expire, but they can be, if the expired ticket gets presented, they can be extended. And there's other issues with Kerberos, you know, like golden ticket and silver ticket, which are kind of out of scope for today, but still good to know about. So, you know, the things we talked about so far, credentials in memory, pass the hash, pass the ticket, I think are all pretty well known among the blue team. Now, but Windows, I think the same can't be said about Windows access tokens. I remember I did a class a few years ago with Dave Kennedy, and you know, he showed us how to use incognito, steal tokens, and to privilege users. But I really didn't grasp fully what I was really doing. And to be honest with you, I didn't really know Windows access tokens existed until fairly recently. But to kind of quickly explain or go over what Windows access tokens are, when you log into a system, it verifies your password, checks if your password is okay. If your password is okay, the token gets created, and every process that gets executed on behalf of that user is going to have a copy of that token. And the tokens get stored in memory, and they basically enable single sign-on functionality within Windows. So there's a couple different types of these tokens. There's impersonation tokens. And if you saw the Rotten Potato talk yesterday, they were talking about impersonation tokens there. These are generated by non-interactive logons. These can be used to escalate privileges, but they can only be used locally. And then there's delegation tokens, which are generated by interactive logons, and these are really the ones that an attacker wants to get, because if an attacker can steal a delegation token of a privileged user, they can use that user credentials to log on to any network accessible system. So is everybody pretty familiar with incognito and how it works to steal tokens, or have you guys used that before? Yeah? It doesn't seem to be super well known among defenders, so I just wanted to go real quick, a little demo on what it looks like to go from local admin to domain admin by stealing tokens. So you can see here we've got an interpreter shell running as local admin. You know, we could have got this multiple ways. Let's just say it's a phishing email. And now in order to steal or list tokens, we need to be running a system. And so, you know, one way to do that, you migrate to a process that's currently running a system, and then you become running a system too. So this example, I migrated to the WinLogon process. Now on the victim computer, I opened up a computer management box, and in the UAC prompt, I typed in my domain admin credentials, and then I closed the computer management box. Now that left that token of that user on the system. So now when the attacker lists out the tokens, he sees this account that's in the blue team domain admin account, and it's as simple as, you know, impersonate token, and then you steal that token, and you are able to use it on the network to access any system on the network with those credentials. Now, one thing I didn't know until I was kind of preparing for this talk is that the incognito has been around for a really long time. It was written and presented by a guy named Luke Jennings in DEF CON 15, and I know I'm kind of late to the party on this, but his white paper that he wrote for like 9 years ago, it still rings true today. And if you go, he's advocating for a lot of the same things that I'm talking about today. So if you haven't checked that out, it's still worth the read, even though it's 9 years old. So credential theft has been a major issue for a long time. Even in that white paper, he talks about how this is nothing new. This has been an issue for a long time. But there's a couple major roadblocks we need to overcome to combat these issues. Number one thing, IT admins and other people that may not consider themselves security people, they might not truly understand the risk of what we're talking about. Also, change is hard, and usability tends to trump security. As Luke Jennings said in that white paper, and Chris Campbell and Skip Duckwall echoed in their Black Hat paper from a couple years ago, there's no patch for these issues. It's an expected consequence of a single sign-on implementation, and without single sign-on, you have to type your password in 10 times just when your system boots up, right? So, but there is kind of a light at the end of the tunnel here. We have more controls than ever before to kind of mitigate some of this stuff, and it's going to provide so much more value by using some of these controls than any next-gen blinky box that you can go buy. And one of those controls is using privileged access workstations. So, privileged access workstations, or PAWs, the concept, as far as I'm aware, was kind of outlined in the first pass the hash white paper from Microsoft, and then it was expanded upon in a TechNet article from earlier this year. And it could be a much older concept of that. It probably is. But the first I had heard about it was that TechNet article. But at the most basic level, they're hardened admin workstations that are designed to limit your exposure to the types of threats and things we were just talking about. So if your goal is to limit how often privileged credentials get left on systems for attackers to steal, how do you go about doing that? I like to think of it and compare it to network segmentation, where you want to isolate those privileged credentials and keep them off and away from riskier systems and riskier users. And to do that, you need to group the systems and users by privilege level. So the TechNet article references this Active Directory administrative tier model. Basically, what this is it just splits up users and computers into different levels different tiers of access. So you've got tier 0, which is going to be your domain admins, domain controllers. If your domain controllers are virtualized, it's going to be any admin that can administer the virtualized infrastructure. There's tier 1, which is going to be anything that has control over mission critical applications. That's going to be member server admins, member servers, enterprise application admins. And then there's tier 2, which is going to be your user devices and any accounts that have control over the user devices. So the idea here is that you have your domain admin account should never log into anything other than a domain controller. You stay in that same tier. Your member server admin should never log into a standard user workstation. And on a similar thought here, you never log in to a domain controller from the same computer that you're looking at cat memes and checking your email and things like that. Because if your admin workstation gets compromised, so does anything else that you administer from there, right? And that's a really key thing to understand. So, traditional solutions to this problem can be inherently flawed depending on how they were implemented. If you're accessing an admin jump server from a user workstation that you browse the internet and check email from, you have the same problem that we just talked about. Now, you can use admin jump servers in a PAW deployment, but you're going to want to make sure anybody that's accessing them is doing it from a hardened workstation. Now, before you go start configuring hardened workstations, there's some prerequisites you're going to want to consider before you do that. First of all, if most of your users are running as local admin, you're going to want to tackle that problem first, right? That can be a difficult thing to accomplish, depending on how much management buys in just security, the types of legacy applications you run, and things like that. But don't give up if you have a subset of users that you just can't figure out how to get them running as standard users. Don't give up, because there's a ton of value in getting as few people running as local admin as you possibly can. You want to make it harder for the attacker to go from standard. They want to make them go from standard user to local admin and then the system. And if you have legacy applications that maybe don't play well with user account control, you can you think about some workarounds you can do. Maybe you can run that application in a terminal server. If you need to put some pressure on a vendor, if you need more pull with the vendor, maybe team up with other customers of the vendor to try to get them to fix their software. And you can also split up their accounts, give them a standard user and a local admin account, and try to force them to use the standard user account, only the local admin when they need to escalate. You can put the local admin account into the protected users group, which I'll talk about a little bit more in a minute. Your IT help desk people are going to be running as standard users too, and they only use their local admin when they need to. And if you do have that group of users that are non-IT, that need separate accounts for standard and local admin, make sure they're the only local admin on their box and not every box. And the next thing you're going to do is, a lot of small companies, they just use domain admin to administer everything, which is a big no-no. So break out your admins into like member server admins, and also you're going to want to limit your domain admins to as few as you possibly can get. Delegate privileges in AD as you need to, and it's also a good idea if you can to segment each group of admins. So if you've got a couple of admins that only need access to a couple operations servers, you make them their own group. So the TechNet article lists out a couple phases of deployment here. Phase 1 is going to be immediate deployment to Active Directory admins. This is going to be get you up and running using PAWs as quickly as you can to help out your most privileged accounts. Phase 2 is going to be extending PAWs to all users with their admins over mission critical applications. Things like member server admins, cloud services admins. And then there's phase 3 is going to be advanced PAW security, which is going to be adding some additional controls, which I'll talk about. So for the deployment models, there's a couple recommended deployment models. The first one being dedicated hardware, which is going to be where you give admins a dedicated workstation, whether it be a laptop or a desktop, and they have one that's their standard user system. They only use their standard user account to log into that. That's where they check email, browse the internet, things like that. Then they have a totally separate system that they use for administration. They log in with their privileged credential, and they're not local admins on that box. They can't browse the internet, so there's some pros with the dedicated hardware model. It's obviously got the strongest security separation because they're two separate systems. But the drawbacks: takes up more desk space, it's more weight to haul around, especially if it's laptops, and it's double the hardware cost. The other model is simultaneous use. So this will be a hardened host machine, will be your PAW, and you'll have either a local VM that is your standard user system, or you'll access a VM on with VDI or RDP or something like that in a centralized place. And so the pros there, it's obviously lower hardware cost, better user experience, and the drawback is, when you have a single keyboard and mouse, you can tend to type the wrong password into the wrong system, maybe. It's just easier to make those errors. And also, you don't have that separation as you would with the dedicated hardware. So for the simultaneous use model, you can either have that a VM locally on the hardened PAW, that's your standard user system, or you can access it through VDI, or they're managed centrally. The drawback of the VDI method is that if you're offline or you can't access that data center, you can't do your standard user activities until you can access that, so you'd have to be always connected to that. Now when I start talking about this model with other IT people, they tend to say, well, why can't I just have my regular user workstation and have an admin VM on it? It just seems like that makes more sense, it's more convenient. But that brings us back to the same issue we were just talking about, where your user workstation gets compromised, and anything that you administer from there could be compromised as well. Whereas if you flip that around and your user VM gets compromised, in order to get back to the host, you'd need a VM escape exploit or something like that, which I'm sure is feasible, but going to be a lot harder to do. So once you've chosen your deployment model, and you can mix and match that obviously to your environment and what your admins prefer, you can use a couple of PowerShell scripts that actually Microsoft has out on TechNet. And so one will create the new OU structure, one will create the new security groups, put them in the right OUs, and one will assign permissions to the OUs, put them in the right groups. And so when you get the new OUs created, the meat and potatoes of where you're going to be working is the admin top level, newly created admin top level OU. And it creates some other OUs too, but mostly what you're going to be working in is the admin OU. And underneath that, there's going to be tier 0, tier 1, tier 2, and then underneath each one of those, there's accounts, devices, groups, and service accounts. I'm just going to quickly go over the tier 1 OU. So in the accounts OU under tier 1, this is going to be, you're going to put users that are members of domain admins, enterprise admins, or equivalent in that OU. In the devices OU, you're going to put your PAW computer accounts. That's going to be the computer accounts that are PAWs in tier 0. And then under groups, you're going to have, there's some new groups that were created in there, and the PAW users group is going to be the actual users that log on locally to the workstations. Now these are not going to be local admins on those systems. The PAW maintenance group is going to be local admin. If you need to log in to troubleshoot it or whatever, you're going to rarely use that, but that group is going to be the local admin on the system. And it's important to note too, a user should never be a member of both PAW users and PAW maintenance. So keep that in mind. So once you have the OU framework laid out, you can start working on group policies that are going to harden the devices. These are some of the ones that are listed out in the TechNet article, and you could obviously expand on this and do more. But first thing that you'll do is use a group policy to empty all local groups. and just put in the PAW maintenance and the local administrator account into the local admins group. You can grant the PAW users group local login access to the PAW, and then you can use Windows firewall rules to block all unsolicited inbound traffic. You can have a whitelist for certain IPs that you maybe use for patch management, security scanning, things like that. And then you can configure WSS to automatically install Windows updates. For the user GPOs, you're going to want to block internet access for all PAW users, that group that was created. You can do that through group policy, through Internet Explorer proxy settings, or you can use whatever you already have in place. If you have a proxy server or Windows security, web security, whatever you use for that. You're also going to want to restrict administrators from logging on to lower tier hosts, and you can do that with the deny logon rights. So basically, you have your tier 0 accounts. They should not be allowed to log on to your tier 1 systems or your tier 2 systems. And then you have your tier 1 accounts that shouldn't be allowed to log on to user workstations. You can use those login right GPO to do that. So once you have all the policies and the OU all set up, the framework's kind of ready to go, you can start working on your actual hardware. And when you do that, you might want to consider your supply chain and how much you trust your, the manufacturer and suppliers and their security practices of your actual hardware that you're getting. You're going to want to acquire your installation media. So if you can use Windows 10 Enterprise, that'd be ideal, so that you can take advantage of things like Credential Guard and Device Guard. You can use Windows 10 Pro too. You won't be able to use those things. So keep that in mind. You can set a unique complex password up for the local admin account. My clicker just died. You can connect the PAW to the network, join the domain, move it to the right OU, install Windows updates, then the necessary admin tools. And for the admin tools and installation media, you're going to want to obviously verify your integrity on that, and check the hashes, make sure they match. And for any admin tools that you install in the box, you're going to want to really carefully consider the risk and exposure that you're adding to that system. You only want to install stuff that you absolutely need on there. And then you can forward your logs to any SIM that you have or centralize the log repository, and then validate your hardening group policies. And then once you have these deployed to all Active Directory admins, you'll be done with phase 1. So phase 2 is going to be extending this out to all admins of mission critical applications. And this is going to be things, like member server admins, cloud services admins, network admins, things like that. And in phase 2, Microsoft recommends enabling and enforcing restricted admin mode for remote desktop connections. And this is kind of a controversial thing. I think because ironically, when you enable restricted admin mode, you are allowing pass the hash via RDP to the system. The benefit of restricted admin mode is that it leaves no reusable credentials on the systems that you're authenticating to, whereas a typical remote desktop connection will leave the empty hash and Kerberos ticket. You're going to want to weigh the risk versus reward here, and in my mind, if you lock down RDP so you can only RDP from trusted hosts, enabling restricted admin mode, the benefit in not leaving reusable credentials when you authenticate far outweighs any additional risk that gets created by enabling restricted admin mode. So if you do decide to use restricted admin mode, it's off by default. You need to enable it on destination systems of the registry edit. To use it, you just use the restricted admin flag with RDP. And then to enforce it, you do the restrict delegation of credentials to remote servers group policy, and then you link that to any admin computer OUs. Now, a limitation of using restricted admin mode is that when you connect to a system with restricted admin mode, and then you connect to another system from there, you're going to be authenticating with the computer account of that remote system that you first logged into. So, if you have like a network share or something like that, it's going to be using the computer account to log into that. So you just want to keep that in mind. Then in phase 2, you're also going to want to move objects to appropriate OUs, so tier 1 users, groups, and computer accounts. And then you want to also add users to the tier 1 admins group. So that's going to allow you to use group policy to restrict logon to lower tier devices. And an optional step here is you can allow whitelisted internet destinations. So like if you have cloud services that you need to administer, or if you have a vendor that needs to be able to remote in to provide support for their application, you can whitelist their internet destination on the PAWs. Tier 1 admins might need different tools than tier 0 admins, so you're going to want to carefully consider weigh the risks of each tool that you're going to install on those. You can also enable a credential guard at this point. Credential guard is a fairly new technology that the idea is to virtualize Windows services that manage credentials. And the idea is that you're isolating. So if an attacker is running as a local admin with admin rights, the idea would be to not allow them to access those credentials. Yeah, but there are some requirements for that. You need Windows 10 Enterprise 64-bit. You need to have Secure Boot enabled. And if the machine is a VM, it needs to be Hyper-V. And there's also a couple other requirements for that, so keep that in mind. So phase 3 builds on phase 1. It's really not dependent on phase 2 at all. And it adds things like multi-factor authentication, using smart cards, and whitelisting with things like Device Guard and App Locker, which are really awesome controls. I don't have time to dive into any of that, and they're fairly complex. But I'd recommend for Device Guard, if you're interested in looking at that, check out Matt Graber's blog. He's got a lot of good stuff on there. Also, I'll talk about protected users and authentication policies and silos. So, Windows 2-factor authentication solutions, great control, but you got to remember they're not a magic bullet for this issue, for these issues. They do have some limitations. They're only enforced for interactive logons, and if you force smart card logons, the hash won't change for that account. So if an attacker gets the hash of one of those accounts, they could use it to log on with network logons. And now you can mitigate that by toggling the smart card required setting, and you can script that obviously. But I believe that will invalidate any sessions that those users are currently in. So keep that in mind. So protected users group. This is one of my favorite controls. I think mostly because it's the most painless to implement. Basically, just put users in the protected users group, and you get a whole bunch of good benefits from that. Most of your benefits of this are going to be given once you're running 2012 R2 functional level. But you still get a little bit of benefit if you're not quite there yet. And what this basically does is it'll force Kerberos authentication, so you won't use NTLM at all, and it'll force using AES for Kerberos. It'll take your ticket hours from 10 to 4. Your ticket will only last for 4 hours instead of 10. And when your ticket expires, it forces the user to re-log on, re-authenticate. Now, and also in the little graphic down there, the only thing stored in memory for LSAS is going to be the Kerberos ticket. And a feature or limitation, depending on how you look at it, when a user is a member of a protected users group, any system they log onto will not store any local cache credentials. So if you put your user into your PAW user into the protected user group, and then you go home and you're not able to hit the domain controller, you won't be able to log on with that account. So good thing to keep in mind there. So authentication policies and silos, these pair well with protected users group, and they do require 2012 R2 functional level. Now this will do things like you can control where accounts log on, which services they can authenticate to. You can set kind of granular Kerberos ticket settings, and it's a great control as well. Now, some of the lessons learned from my deployment, I know not everyone shares this, but Windows 10 Enterprise has been great for me. Had a really good experience with that. You know, using local VM, you know, having dual monitors and a dock, and the audio and microphone and copy and paste between host and VMs has been great. Also, Hyper-V networking has been great. You can easily put VMs into different VLANs. You can change from the private network to the wired network, the wireless network. Had really good luck with all that. But I'm not going to say that deploying PAWs is going to make anything easier for you. You know, it really is a dramatic shift in the day-to-day of most IT admins. And, you know, even for a small company, you only have a handful or a couple of IT people. The number of privileged accounts you have to manage can seem kind of daunting. And I even found myself kind of swearing at myself for making myself do this. But you know, you get used to it after a while, and the benefits are definitely worth it if you care about security in your environment. And if you need, you just have to figure out what works for you. So if you can't remember all those passwords yourself, you might want to think about an enterprise password product or something, and you're obviously going to want to weigh the risk of that as well. But you just need to figure out what works for you in your organization. Also, you're going to probably want to enable internal web browsing, because you'll probably be managing web GUIs of systems on your network. And if you do that, if you block internet browsing with proxy settings and group policy, one way to do that is the proxy override group policy setting. And also, I found it useful to script virtual switch config changes using PowerShell, like if I'm switching locations, scripting those things to make it faster. Okay, so that's kind of the PAW deployment. I'm going to switch gears here a little bit and talk about other things you can do to limit exposure to credential theft and lateral movement. And the first one here being network segmentation. And you know, I kind of compared privileged access workstations to network segmentation. In theory they're similar, but I've also found through my deployment that they also pair well with network segmentation. So you know, if in this made-up example here, if we have 3 offices, and each office has a different subnet for different user groups. So you've got legal, accounting, HR, and IT. And you know, if you start talking about network segmentation, you start thinking about things like, okay, my accounting users in Site 1, do those PCs need to talk to other users in accounting at Site 1? You know, I don't know. It depends on the business. There could be a reason, but probably not. Another situation would be like, my users in legal in Site 3, do those computers need to be able to talk to any other computers in any of the accounting subnets? You know, maybe. But if they do, why do they? And can we figure out a workaround so that they don't have to talk directly to each other? Now, an example of that would be like if your legal users in Site 3 like to share screens and help each other out with the legal users in Site 1, maybe you can use some kind of a cloud remote support service so that they can still view each other's screens, but they don't have to talk directly back and forth to each other. That would be a workaround so that you could still segment those networks. Now, one way to do the network segmentation is to use layer 3 ACLs at the router level to block access from each subnet from each other, and then use VLAN ACLs at the switch level so that users within the same VLAN can't talk to each other in the same VLAN. So in an ideal situation here, your legal users in Site 1 wouldn't be able to talk to any computers in any of the accounting subnets, any computers in any of the HR subnets, or even any of the computers in any of the legal subnets. But they'd obviously still be able to hit the servers subnets that they need to they'd obviously need to be able to hit the IT subnets too, so they can be managed by IT. So, just thinking about those things, if you drop an attacker into an environment where they can't talk to any other user workstations, I think you're going to make their job harder. And if on top of that, you're doing some of these controls to limit credential theft, you're gonna make their job even harder. So that's the kind of the logic there. Some of the other things you can do to limit credential theft, or specifically lateral movement in this case, randomize your local admin accounts. Use something like Microsoft Labs or similar. In that Mimikatz KB, they give you a couple new SIDs, user SIDs. So you can use the local account there where it says S-1-5-113 local account. That's going to be, you can use that to deny network logon to other systems, so that in that first example where you dump credentials and you move laterally with local accounts, that will not allow that anymore. That's a huge quick win. If you're not doing that, make sure you go home and do that right away. Also, you can disable LLMNR and NetBIOS if you're familiar with like Responder and how that works. You're obviously going to want to limit your service account privileges to as little as possible, and use managed service accounts whenever you can. And you're going to want to force NTLM v2, and if you can, disable. Some people say disable NTLM altogether. I think that's great if you can. Not everybody can probably do that, so you're going to want to at least force NTLM v2. And so to kind of wrap up here, I hear people talking all the time about these next-gen appliance or software that stops every threat known to man and has machine learning and APT detection and probably wipes your ass and stuff for you too. Those sales and marketing people at those companies are really good at what they do. They've got really sexy graphics and everything. And it's so much easier to go buy one of those things, wrap it in your network, and then say, all right, we're good, we're protected, let's go to lunch, guys, than to really sit down and truly understand the risk that you're dealing with. And, learning from some of the offensive guys, taking their tools and trying to learn how they work. Things like Power Up and Incognito, and, run those things on your own Mimikatz, run those on your network, and use them to try to figure out how they work. Not necessarily blocking those tools, but figuring out how those tools work. Finding your weak points, building walls, set as many tripwires as you can, and plug the holes the best you can. So, just wanted to say thank you to a bunch of people on Twitter that put up with me asking dumb questions. If you're a blue teamer, these are definitely people to follow. Also, I didn't mention Carlos Perez, but also follow him. A lot of good stuff there. And I also want to mention BreakSec podcast and Defensive Security podcast. Really good stuff if you're a blue teamer. So I don't know if we have any time. I think we've got 3 minutes for questions, comments. Yes, I believe they do get cleared on a reboot. Yep. I'm not doing much with V-switches. I'm mostly working with physical hardware switches. And actually on this slide deck, there's a config for VLAN ACLs, and that's what I use. And if you...
I'm talking more about
that sounds like a kind of a more specific question for you, maybe your organization. I don't have a good answer for that one. Sorry. All right. Well, thanks everybody for coming. If you want to.